All right, we are at 2 minutes after the hour, so this is when we're going to start. Thank you all for joining. We have some great list of attendees, a lot of friends. I see a lot of names of friends in the list of attendees, so glad to see that. All right, we'll begin our presentation now. So first off, I just want to welcome you all to our webinar, where we're going to be showcasing our scenario analysis capabilities with Design Pro. Design Pro is really the foundation of our PlantPredict Pro suite of tools. And so we're going to be giving you a demo of Design Pro so that you'll have all the information you need to try it out for yourself. First thing we'd like to do is introduce our presenters. We'll begin with my co-presenter, Ben Shapiro. Ben, please tell the audience a little bit about yourself.
Hey everyone, thanks for joining. My name is Ben Shapiro. I've been at Terabase doing software development and product for about 3 years now, and before that I was automating design of the development team at First Solar.
Thank you, Benj. And I'm David Spieldenner, product director of PlantPredict. I've been working in the solar industry for 17 years. 15 of that was with First Solar. I ran the IT team for the EPC division of First Solar, and then pivoted my career in 2020 and took over PlantPredict and has been running PlantPredict ever since. Got acquired by Terabase in 2021 and been focusing on growing the PlantPredict product as a member of the Terabase Energy team ever since. All right, speaking of Terabase Energy, we are a Berkeley, California-based startup founded in 2019. We're building digital and physical solutions to help accelerate the deployment of solar. And that's what you see on this slide here. First on the left, we have our software services for the development and pre-construction phases of the project. Central to this is PlantPredict, our solar energy modeling engine. And we've been expanding PlantPredict into a full suite of professional design tools, including layout automation, material estimation, economic modeling, and grading analysis. We also have construction products and services, including our construction management and monitoring software called Construct. For the physical world, we've built a construction automation solution called TerraFab, where we bring a mobile factory to your project site, complete with an assembly line and rovers to automate the module to torque tube to pile assembly. And we just completed our first full deployment in Arizona, and we're looking forward to ramping up several more deployments next year. Finally, we have our plant controls team that provides a full set of SCADA and power plant control services, including hybrid control systems. We've recently started offering a PlantPredict SCADA module that integrates your energy model into your on-site SCADA system to improve your actual versus expected monitoring capabilities. You'll have a chance to learn more about this at an upcoming webinar that we have planned for early in 2024. Focusing in on the PlantPredict suite of tools, we have built our PlantPredict Pro tools to sit on top of our PlantPredict bankable energy model and perform sophisticated studies easily and quickly from within your browser. Design Pro, which we'll be demoing today, generates a detailed layout, 25-line BOQ, an EPC cost estimate, and a financial model for your project site, and allows you the ability to run a batch of scenarios for your simulation to find the optimal configuration. Voltage Pro is designed to enable a simulation-based approach to string sizing. We have done 2 webinars over the past year that focus on Voltage Pro and are published on our Terabase.energy website, which I recommend you checking out if you're at all interested in Voltage Pro. Terrain Pro is our latest Pro tool. Having just been released in October of this year, Terrain Pro drastically simplifies the process of generating an earthwork assessment for your project site and is specifically designed to assist in the evaluation of terrain following trackers. We did webinars in August and October that really focused on Terrain Pro, and you can also find those webinars on Terabase.energy website, and I recommend you checking those out. For today's agenda, we are going to start with an overview of Design Pro and why it's really important to the industry. From there, we're going to talk about our new scenario analysis capability and the GCR capacity graph that is the focal point of this new feature. Benj will then take you through a live demo of Design Pro software, starting with the basics of setting up a project and then digging deep into the scenario analysis. We will then go over our product pricing and the changes that are planned for 2024, and then wrap up with some Q&A. Before we go too far into the weeds, we're going to kick things off with our first poll question. So poll question number 1. Who does the first design of your project? Is it the land prospector, the solar developer, the development engineer, or you just let the EPC take care of it? So I'll give you a few minutes for you to submit your responses, and we'll see what we got. All right, the responses are coming in. Very interesting. All right, we are sharing the results now. So as you can see, most people leave it to either the developer or the project development engineer, which makes sense. We love to see that process move further forward in the life cycle, and we love to see that developers are doing their own designs. That's what we personally think is important for the industry. So that's great. All right, moving on with the presentation, let's talk about Design Pro. So as you can see on this slide, Design Pro is intended to span the entire project lifecycle from site definition all the way through financial modeling. So that's really what Design Pro is designed for. Beginning with site definition, Design Pro has access to several GIS layers that can be very useful for informing your site plan. Starting with a parcel database, you can easily create a site boundary with the click of a button. Pull in wetland layer to make sure that you don't place solar on top of a protected zone. See the energy infrastructure that's installed near your site, such as transmission lines or substations, and even pull in a high slope layer to identify if topography is going to be a challenge for your project site. Design Pro users can collaborate with their GIS team by importing and sharing GIS layers. You can also import site boundaries or exclusion areas via KMZ or KML files and easily define the shapes with the click of a button. You'll need to define your site substation because Design Pro will wire up all your solar panels to inverters and then connect those inverters to the substation in order to calculate cable lengths and trenching requirements. You can also customize your site design parameters such as the road widths and exclusion area setbacks and linear exclusion setbacks as well. From there, you'll specify the solar panels, the racking configuration, and the inverter that you want to design with. We have quick selection tiles to simplify this process, or you can customize your selections if you want to dig into the details. Using the module and inverter library from PlantPredict, you have access to thousands of global files, or you can upload your own PAN or OND files to build out a module and inverter library that is controlled and accessible only within your organization. When making your racking selection, if you're planning to use a single axis tracker, you can choose between our generic tracker or our 1P multi-string tracker, which will lay out full and partial trackers on your site. Pay special attention to the tracker configurator because there are many parameters that you can utilize, including the tracker minimum pile height and the pile reveal window that will automatically be passed to Terrain Pro for your earthwork assessment. Next, we will go into the scenario analysis screen, which will be the star of today's show. Our scenario analysis page features DC capacity versus GCR graph that visualizes the relationship between your site capacity and the ground coverage ratio that you need to use to hit that capacity. Enter your design requirements, such as your target GCR, your inverter load ratio, or your expected site capacity in either megawatts AC or megawatts DC, and the graph will automatically shift to show you what you can expect based upon the site plan and the equipment selection. Add up to 50 configurations to run a batch of scenarios, and you can simply queue them up, kick them off, go grab a cup of coffee, and come back and analyze the results. Each scenario will have a unique layout that includes a 25-line detailed BOQ, everything from modules to inverters down to cabling and trenching, all the way down to roads and fencing are included in that BOQ. Then that bill of quantities is used to generate an indicative EPC cost estimate, which Terabase offers you some default assumptions, which you can use, or you can input your own cost assumptions and have that run against that BOQ. The cost estimate is going to include material, labor, and overhead costs. Design Pro also takes and passes that detailed power plant configuration over to PlantPredict. It'll generate a block builder prediction in PlantPredict, which then gets you an accurate and bankable energy yield result for your scenario. The cost estimate and the energy yield report are then passed into our financial model, which allows you to solve for LCOE, IRR, and NPV. You can once again use Terabase defaults or input your own financial assumptions, including weighted average cost of capital or project life. Since each scenario is run independently and the results are unique to that scenario's configuration, you can order your scenarios by LCOE, cost, or yield and determine the optimal project input parameters for your site. I realize that we went through these slides quickly, and the reason why is that Ben's just going to give you all this information again, just in our demo. So before you ask, these slides will be made available and will be sent to all webinar registrants after the conclusion of this webinar. So you'll be able to scroll through these slides at your own pace and see all the pictures that we included. The last thing I want to point out is that we have our Design Pro user manual on our PlantPredict.com website. So that to see the user manual, you'll want to go to www.plantpredict.com. There's a wealth of information available, including step-by-step instructions on how to use Design Pro. All right, it is now time for our second poll question. So our second poll is, what is your primary objective when using design software? Is it finding the right site for your project, maximizing capacity for a site you already have, identifying the lowest possible ground coverage ratio, optimizing for DC to AC ratios, or is it simply all of the above? We'll give you a few minutes to answer this question. All right, the answers are rolling in. All right, the results are in, and as expected, people overwhelmingly have chosen that they do all of the above, which makes sense. And I am happy to report that PlantPredict's Design Pro does it all. So all of those options, whether it's site selection, capacity maximization, optimization, all of those things are possible with Design Pro. And so with that being said, it's time to hand off to my colleague, Benj. So Benj, I'm going to let you take over from here.
Thanks, David. Thanks for the intro. Let's take a look at Design Pro's updated scenario analysis page. The scenario analysis page is where scenarios are designed and added to a simulation. In Design Pro, each layout is referred to as a scenario, and each scenario has a distinct combination of GCR, capacity, and DC-AC ratio. The page consists of three components. On the left here, we have the design inputs, which is where you can enter targets for the design parameters of your layout. In the middle is the GCR capacity visualization, which is a graph that represents the maximum DC capacity for any given GCR. And then on the bottom is the scenario tray, where scenarios that have been added to the simulation can be viewed. Design inputs are the parameters that make each layout unique. If you have a specific target for a design input, you can enter it here on the left. If you don't have a target for a specific input, that input can also be left blank. If the inputs are left blank, they will either be set to a default value or they will be calculated automatically. The GCR capacity visualization graphically represents the maximum DC capacity achievable at various ground coverage ratios based on your site plan and equipment configurations in the simulation. The visualization is created by running many layouts with different GCRs in the background. The x-axis is the ground coverage ratio, and the left-hand y-axis is capacity, both in DC and AC. The right-hand y-axis shows inverter quantity. Both sides of the y-axis share a uniform scale. The orange line is the maximum DC capacity at any given GCR. As the GCR goes up, more modules can fit in the same amount of space, and the maximum DC goes up as well. The visualization also shows information about the current layout or scenario that is being designed. The different dots on the screen represent the design parameters that are going to be used in the layout. The white dot with the black outline represents the DC capacity that will be used in the layout, and the blue dot represents the AC. The design inputs here are GCR or row spacing. Since they're directly related, if you enter one, the other one will populate. I'll put in 0.4 here. As I enter 0.4, you can see that the GCR part of the graph has shifted to the right to match the input. DC capacity, I'll enter here 120. You can see that the DC capacity dot has shifted down to 120, just like the input. DC-AC ratio at the inverter, also known as ILR or inverter loading ratio. This is an average DC-AC for the entire site. I'll put in 1.3. And then AC capacity at the inverter. You can also enter inverter quantity. Right now, we're at 91 megawatts AC at 29 inverters. I can also add inverters here. I'll click this button to add inverters. As I'm adding inverters, you can see that the inverter quantity on the right is updating. There's also DC-AC ratio minimum and maximum. Those are at the individual inverter. If you want to bookend the minimum or maximum DC-AC ratio for any single inverter on your site, you can do it here. Adding values here makes for a more consistent DC-AC ratio from inverter to inverter, but this also may reduce the maximum capacity of your site. When you've entered all the values for the scenario, you can press the Add Scenario button here to add the design to your simulation. You can see that the graph and inputs reset so that you can add another scenario if you want. You can add up to 50 scenarios to one simulation and run them at the same time. Since we've added one scenario to the queue, we're able to add 49 left here, and you can see how many scenarios you have left in the counter. Let's use Design Pro to develop the Penny Lake Solar Project in Minnesota. We're looking for a site that can fit at least 140 megawatts DC at a 0.3 GCR. The first thing we need to do is find a site plan that will hit the targets for the project. Here's our original site plan. It's a nice piece of land with an exclusion around Penny Lake and a few more around the houses on the property. To see if the site will meet our targets, let's enter our targets into the design inputs and then look at the visualization to see if they're feasible. So I had 0.3 here, and then I had 140 megawatts DC were our targets for the site. As I enter the values in the design inputs, the visualization updates so we can see how these values relate to what's possible on our site. Since we've entered 0.3 in the GCR, we are locked into that GCR here at 0.3 on the visualization. It won't move, and the layout for this scenario will always have a 0.3 GCR. Our 140 megawatt DC capacity target is showing up as red on the graph. This is because it is over the maximum DC capacity possible at the given GCR. So we've got this orange line showing the maximum DC capacity, and this 140 megawatts is over that. At a 0.3 GCR, we can see that the maximum possible DC capacity is on this line here at 108 megawatts DC. Design Pro will automatically create a layout that's as close as possible to your target capacity. So in this case, that'd be 108 megawatts DC. For this demonstration, I've run a few layouts in advance. I'll switch over to another tab to take a look at how the results of this layout will look when we run the simulation. Here's a layout for the scenario that we just created. The different colors on the screen each represents a different inverter block. So this is one inverter block, and then this is another one, etc. Each block has a yellow road in the center, right here and here, along with a red inverter. So zooming in, you can see there's a red dot for the inverter, and we're placing an inverter for each AC block. Each module is wired to a combiner box, and then that combiner box is wired to inverter, ensuring that each block hits DC-AC ratio targets. You can also render the layout in a tracker view. So you can zoom in and view the individual trackers, and you can see the inverter, the roads, and the trackers. So here's what our layout looks like from the top. Taking a look at the layout, we can see that all the space has been used. There's modules up into the corner here. And still the target capacity can't be hit. At the bottom here, remember, we want it to be at 140 megawatts DC, but we're only at 108. This means that we're going to have to find a larger site plan if we want to make Penny Lake Solar work. Okay, so let's take a look at another possible site plan here. Okay, so I'm moving to the site plan here. So let's take a stroll down the road and talk to the owner next door. She agrees to sell her land all the way up to the Cobb River, which is this river here on the right. Now we have some more buildable area to work with. Here's our add land site plan, and it contains all the land we had before, but now stretches further east. And let's see if that's enough to hit our targets. So now I'm going to create a new simulation with this add land site plan, and we're going to analyze that. It'll take just a few seconds here to load the graph and the visualization. That's those layouts running in the background that actually creates the visualization and can tell us before even running a single layout what the maximum DC capacity is at different GCRs. I'm going to enter the same 0.3 GCR and 140 megawatts DC into the design inputs. 0.3 on the GCR, 140 megawatts DC. This time, as we input the DC capacity in GCR, we can see that the DC capacity input is below this orange maximum capacity line. That's why it's showing up in black instead of red. This means that we can hit our target DC capacity and GCR with the add land site plan. So let's take a look at the layout. Here's a layout with the add land site plan. And you can see that we have this extra space on the right. We're able to hit our targets with room to spare. On the bottom here, looking at our DC, we're now at 140 megawatts, but the GCR is still at 0.3. The gray trackers in the top right are trackers that are not being used. This is because they are not needed in order to hit our capacity target. Why are these unused trackers in the top right? It's not because solar panels prefer a lake view to a river view. The reason is that the unused trackers are on the top right is because they are the furthest away from the site substation. Placing the site substation is part of creating a site plan in Design Pro. The substation is this purple square here at the bottom left. The Design Pro uses trackers closest to the site substation first. This optimizes the design by reducing wiring costs and electrical losses. Great, now we found a suitable site plan for Penny Lake Solar. It's exciting to have a site plan to work with, but what about all that unused space in the top right? Let's find the maximum amount of capacity that we can fit in our new site. I'll go back to the scenario analysis. Let's stick with our target of a 0.3 GCR, but this time not put in any value for DC capacity. So I'm deleting this 140 megawatts on the DC capacity. When the DC capacity input here is left blank, Design Pro will automatically solve for the maximum capacity at the given GCR. On the visualization, we can see that the DC capacity is now sitting on the maximum DC capacity line. Below it was locked into 140 because of our input, but now it's shifted up to go as high as it possibly can, which is at that maximum DC capacity line. We can now fit 155 megawatts DC instead of 140. Let's take a look at the layout. Taking a look at the layout, we can now see that the site plan is completely filled. So we had all these gray trackers here on the right because we were stopping at 140 megawatts DC, but now we can see that our DC here at the bottom is 155 megawatts, even though the GCR has stayed the same. All the trackers that can fit in our site are now being used at a 0.3 GCR, thus maxing out the DC capacity. Your boss is going to be pretty happy with all this excess capacity. It's great to maximize capacity, but it might not always be the goal. We had a target of capacity 140, so let's stick with that, but see how low we can get the GCR. Going back to the scenario analysis page, a lower GCR means a wider space between rows of trackers. The further away trackers are from each other, the less they shade each other, which leads to higher yield. To find the minimum GCR for a specific capacity, enter the target capacity, but leave GCR blank. So I'm going to put 140 megawatts back into DC capacity, and then I'm going to delete the GCR. The calculated value will be the lowest GCR where it's still possible to hit your target capacity. On the visualization, we can see that the GCR is shifted from 0.3 to 0.271. This is the GCR where maximum DC capacity on the site is equal to inputted DC capacity. So you can see here we've shifted to the point where our 140 is on this maximum DC capacity line. Lowering the GCR any more would mean that the trackers would be too far away from each other to fit enough on the site to hit our target capacity. Taking a look at the design, we can see that the whole site is being used, but the DC capacity is still 140 megawatts. The GCR is shifted to the exact point where the whole site can be used given the target DC capacity. So we're now back at 140, but our GCR is dropped. The panels are spaced out a little bit. You can see that the blocks are a little bit wider, but we're still using our whole site. Now that you've found a suitable site for your project, you know its maximum capacity and minimum GCR, you can take a look and further optimize the site. Let's use the time that we've saved here, because that's only taken a few minutes, to optimize our project looking at DC-AC ratio. Design Pro can easily run multiple layouts with different DC-AC ratios at the same time. Let's stick with the maximum capacity at 0.3 GCR. So I'm going to go GCR, and then I'm going to stick with the maximum capacity by leaving that blank, while creating a few designs with different AC capacities and DC-AC ratios. I'll start by entering a 0.3 GCR up here, and then leaving the DC capacity blank. Then I'll enter 36 in for the inverter quantity, and I'll add a scenario and then add a few more layouts, going up one inverter every time. So I've added that 36 inverter quantities, and then I'll go to 0.3 GCR again. I'll type in 37. As you can see on the right here, as I'm changing the inverter quantity, the visualization is shifting to show that. The megawatt AC capacity is also shifting accordingly, so it's going up by one inverter, and the DC-AC ratio is also changing. So I'll add that 37. And then I'll add two more here. So I'll go 0.3 and 38 inverters, and 0.3 and 39. So here are the four layouts. We can see that the target GCR is always 0.3, so that's staying constant, and the target DC is always staying constant at the maximum we can fit at 155 megawatts DC. What's changing is the DC-AC ratio and the target AC. We're starting at 113 AC, and then we're adding inverters every time, and that's causing our DC-AC ratio to shift because DC is fixed. What we're left with here is four layouts that have run at the same time. You can view different layouts by clicking on their respective row in the scenario tray. So I just click to that second layout, and we can see that here. Each of the four scenarios has a unique layout, bill of quantities, yield, EPC cost, and LCOE. Those then can be used to determine the optimal layout for your site. In summary, I've showed how to find a site for your project, maximize capacity, minimize GCR, and run a DC-AC ratio sensitivity. When I was working in First Solar's development office, I saw this process takes weeks to turn around, and Design Pro can be done in less than 15 minutes. Back to you, David.
Thanks, Benj. That was great. All right, let me return to sharing my screen. Okay, there we go. All right, thanks again, Benj. We'll move on with poll question number 3. So, what characteristics of the design have the biggest financial implications for your project? So what do you think? Is it the equipment selection, modules and inverters, or racking configuration, your capacity, be it DC or AC capacity, your ground coverage ratio, impact on energy, or just maximizing your land usage? If you please give us your answers there and let us know what you think. Poll questions or the poll answers are coming in. It's looking like we have a clear leader. All right, the poll is now closed, so we're showing the results. Looks like people are saying it's the DC or AC, or DC and AC capacity. So getting your inverter load ratio correct is what people say. We also have land use on there, which is good, and I think that probably ties into some of the grading requirements and earthwork requirements. All right, we are nearing the end of this webinar. If you have any questions, please fill them out, put them into the GoToWebinar question area. We'd like to get some questions queued up so that we can pass that over to Benj here in a minute. But before we go there, I'm going to talk about our pricing. So as you can see on this slide, we are planning to increase the price of PlantPredict Pro starting on January 1st of 2024. The cost of an annual subscription is going to be going up from $6,000 to $7,500, which includes up to 3 users and provides access to all of our Pro tools, including Design Pro. If you want more than 3 users, we sell additional user licenses, and the price of individual user licenses above 3 is going from $2,000 per user per year up to $2,500 per user per year. If you're part of a larger organization, you can always subscribe to our enterprise plan, which features up to 10 users at a cost of $20,000 per year. The base price of our enterprise subscription is not changing as we head into 2024. This is going to offer a volume discount when you compare it to 10 users on the Pro plan. You basically get 2 users for free when you subscribe to PlantPredict Enterprise over PlantPredict Pro. We also sell additional incremental enterprise users for $2,500 per user per year. And if your organization is large enough that you need more than 20 users, we do offer some additional volume discounting, but you will need to talk this over with one of our sales representatives and get a quote. The last thing I want to mention is that we will be rolling out PlantPredict 3D in 2024. We plan to price this capability with a credit-based system. PlantPredict 3D is really a major step forward for the industry and the ability to do 3D modeling within PlantPredict. It's going to be available to all of our paid subscription tiers, including individual, but you're only going to get to see those 3D results if you pay for the credits. More details are going to be coming soon about that. All right, before we get started into Q&A, I wanted to let you all know that we're already working on our next webinar, which is planned for January 11th. So just after the holidays, we will be introducing our PlantPredict SCADA integration, which is really quite amazing. So the idea there is you're going to be running a physics-based model on your power plant that gives you the ability to dig all the way down into inverter performance, but you're going to be running that near real time, which is something that just doesn't exist in the industry up until now. So you're going to want to check that out if you're considering SCADA decisions on any of your projects and you're a fan of PlantPredict. You're definitely going to want to check that out. Watch your inbox for registration instructions. We also would like to mention that we're going to be exhibiting at Intersolar North America in San Diego in January. Benj and I are both going to be there. So if you want to meet us in person, please stop by and say hi. We're going to be in booth number 534. We're going to be doing demonstrations of the software there. We might even get a sneak peek at PlantPredict 3D. So we'd love to see you. Please stop by, meet us in person, and we'd love to talk to you. All right, and with that, that is all of our prepared remarks, and we are now going to transition into our Q&A session. And so let me see here. I'm going to pull out our questions. All right, the first question. Benj, I'm going to pass this over to you. So can you remove inverter blocks that are not preferred or put some kind of preference to avoid like long split blocks? Like how do you kind of control the inverter blocks that are appearing?
Okay, yeah, so in the equipment selection, which is where you choose the modules and inverters for your site, there's an advanced settings, and there's an advanced settings called tables per row, or tables per rows high, pretty much, and that pretty much is the amount of tables high that the blocks are, so the amount of trackers, and you can pretty much change the shape of the block based on saying I want this many trackers on the north side of the block, the north side of the road, and this many trackers on the south. And so if you have less trackers high, essentially, you're going to have a kind of a wider, more square block. And if you have more trackers high, then you're going to have those skinnier, taller blocks. So you're able to toggle and choose that.
All right, very good. Let's see, for cases where you have a parcel that does not have enough space for a full inverter block, are you able to input a max inverter loading ratio?
Yeah, so on the scenario analysis page, we didn't do a demo use case as part of this, but those bottom inputs were DC-AC ratio minimum and DC-AC ratio maximum. And while there's just the DC-AC ratio input, that's a site average. But if we're looking at the DC-AC ratio minimum or maximum, those are for any specific inverter. So if you put a number in the minimum, no inverter on your site will go below that minimum. And then the same thing for the maximum. So if you put a maximum value in there, every single inverter will have to adhere to that maximum, and no single inverter will go over that DC-AC ratio or inverter loading ratio maximum.
All right, very good. Yeah, here's a question for you. Can I use the scenario analysis tool with a fixed tilt rack?
Yeah, absolutely. All major racking systems are able to be modeled in Design Pro. We have a fixed tilt option for equipment where you can fully design a fixed tilt, however many modules high or wide you want to have that fixed tilt. That is 100% possible.
Okay, great. Do we have the ability to sort the various modeled scenarios by parameters such as AC megawatts or LCOE?
Yeah, you do. On that, when I was looking at the layouts, you could see that there was various parameters about each design, whether that be DC, AC, LCOE, etc. And if you click on any of those parameters at the top, you'll see that there's an arrow. And when you click the arrow, it'll sort from highest to lowest. And so all of the scenarios that you've added to that queue, whether it be 1, 2, or 50, will then be sorted in order from highest to lowest. You can then take that a step further, and if you say you have 20 different scenarios and you want to compare maybe the top couple LCOEs or the lowest LCOEs, you can actually click the compare button, which is also on that scenario tray, and you can choose the scenarios you want to compare, and then that'll pop up an additional screen where it will show more detail of those different layouts side by side. It'll show details about the BOQ, about the costs, about different quantities of equipment, etc. And you can either view that in the screen, just in the UI, or you can create a downloadable Excel deliverable based off that.
Great. What kind of file formats are you able to export the layout into? Like AutoCAD, PDF? Let us know, like, how do we get access to that layout?
Yeah, so also on the scenario tray, there's a little download icon. So for each layout, we create a ton of different deliverables. We create a full EPC cost estimate that's over 30 lines. There's an 8760 and like a power plant performance summary, a full financial model, but also in terms of layout, you can download a KML of your site that'll include trackers, site plan, roads, and then you can also download a PDF of your layout. So you can take kind of an array layout PDF, and it'll create a document that shows the capacity and a picture of your site, and it's a really nice deliverable to show to landowners or to use for permitting.
All right, I'm going to actually take this next one, Benj. So a question came in asking about when designing a layout in PlantPredict, how does PlantPredict take into account the shading effect of different modules on each other? And so, PlantPredict does currently row-to-row module shading, and we have a 2D calculation model that understands your sun position in the sky and how that is relative from one row to the next row. And it does understand, based upon the ground coverage ratio, how much space is there, and it will calculate the amount of shade that's going to come from one row to the next row. So this has been something that's been part of PlantPredict for a long time. It's core to energy modeling, and so that's how it is. I mentioned the PlantPredict 3D. This is really our big step forward, and that's coming out next year. We're really excited about it. What we're going to do is, above and beyond just the 2D shading of row to row, we're going to understand how the topography. So if there's hills and stuff on your site, some rows are going to be higher than their neighbor rows, and modeling that is a much more technically challenging problem. And so we've got an approach that we're building out right now that we actually have it working within our development environment. We're just working on putting the final touches on it, and that's something that we're going to be planning to roll out. So I'm glad we got that question. All right, another question for you, Benj. Where does Design Pro get its costs for its cost estimate? Is it utilizing RS means, or where's it coming from?
Yeah, so there's actually in the background, we're running like an 180 line item bottoms up cost estimate. There's lots of different components to this, but typically there's two different kinds of line items. They're ones that are cost of equipment. So whether that be cost of inverters or cost of setting up a temporary office, we have a database of equipment costs as well as construction costs. And yes, a lot of those construction costs do come from RS means. Also, there's a lot of those line items that are done calculated by using the cost of labor. So for example, I have to install, thousands of torque tubes. We know how long it takes to install the torque tube and how many are installed. So you get like a total time of torque tubes being installed. And then we assign a different labor class to that. So it'd be like a general labor installing the torque tubes. And then we have a cost for that labor that does come from RS means as well. They have a state-specific database for different kinds of laborers, and then we assign that cost to that amount of labor and then figure out how much it would cost to do that total part of the construction. So we do that a bunch of different times for different equipments and different labors, and that's how we get the EPC cost.
Very good. One thing, the question did come in, and we probably should have mentioned this earlier, but we will be sharing a recording of this webinar. It'll be on our terabase.energy website, just like all the other webinars. And we'll also be emailing this out to everybody who's registered for the webinar, so you can look forward to that. So Thanks for keeping us in line and asking that question. Another question is, how do I upload modules or inverters into Design Pro?
Yeah, so that's actually done through PlantPredict. So PlantPredict is our kind of ecosystem where we have a library of modules and inverters. So on the PlantPredict webpage, on the left-hand side, there's a ribbon, and it's right below projects. It says modules and inverters. And what we have is we have a global database of modules and inverters that we keep up to date and is freely accessible to everyone that uses PlantPredict. But you can also upload your own, like you were saying. And when you click on that module or inverter screen, on the top right, there's upload your own module file and upload your own inverter file. And that will take you to a screen where you can upload a PAN file or an O&D file directly, and it will parse those out and create a module or an inverter file for you to use in PlantPredict and also in Design Pro, because Design Pro uses that database as well. And when you upload a module or inverter file, those will be private just to you, and then you can also make those available to everyone in your company. So it kind of takes away having to share, different module files via email and remember which one, exactly you're using for each specific design. It creates a uniform cloud-based database of those module and inverter files that's available to only the people in your company.
Very good. Here's a question for me. So I'm going to take this one. The question is, if I want to purchase a subscription to PlantPredict Pro that's more than 1 year, is that possible? So it's a good question. I just want to go over once again for the pricing purposes. If you are interested in PlantPredict Pro, you can still subscribe to PlantPredict Pro between now and the end of the year for $6,000. So 2023 pricing is good all the way till the end of the year. So if you're interested, definitely reach out. I need to talk to you like pretty soon because the month is getting away from us. If we've got a proposal in process before the end of the year, we'll honor that pricing, even if you don't actually sign up until January. But we got to have a proposal with a December date in order to have that pricing. And absolutely, if you want to subscribe to a 2-year subscription, we are offering 2-year subscriptions, so you could lock in that $6,000 price for 2 years. The only catch is you would need to prepay. So our annual subscriptions are prepay, so you would pay upfront the $12,000, but that would lock in that $6,000 price for the next 2 years. You'd have price certainty. You would know what you're paying for the next 2 years, and that would all be just taken care of with that subscription. All right. Let's see here. Another question is, can I use a KMZ file to define my site boundary or constraints? I'll let you answer that one, Benj.
Yeah, definitely. So you're able to, when you're creating a site plan, there's a couple different ways you can do it. We've got a parcel layer that you can click on and create boundaries based off the parcels. And we also have exclusions that you can create exclusions based off different layers that we have, like slope or wetlands. But a lot of times you're working with a site plan that's been created elsewhere. And whether that's a GIS team or another software that's for creating site plans like Transect. And you can just directly upload that into Design Pro, and it will parse it out for you and turn that KMZ or KML into a site plan in our software that you can then use and create designs on top of.
Okay, very good. We got a question in from Michael. This is kind of more of a suggestion, but I like it. When the new 3D comes out, with the site layout PDF in 3D happen? It would be fantastic to show the landowner possible isometric views. So we'll take that into consideration, Michael. Thanks for that suggestion. We haven't given that much thought, but providing a image in the PDF in 3D is kind of a cool idea. There's another question coming back to the PAN and O&D files uploading. Is it possible to upload more than one PAN and O&D at the same time? So I'll answer that one, Elvar. So no, we only allow you to upload one pan and O&D file at a time through the user interface. It's one of those things where I don't think you were asking this, but it's just worth noting. PlantPredict does have an API that's accessible to our enterprise customers, and our enterprise customers, with that API, they can do certain things. And one thing that I know you can do through the API is you can actually upload a batch of pan files or O&D files all with a single script. And so I know because we do that. It is possible through the API, but through the user interface, we don't give you the ability to batch that. That's a good suggestion, though, and something we may want to consider in our development roadmap. All right, Peter's asking, what's the timeline for the 3D release? You know, that's a great question. I mentioned that it's planned for 2024, and it's going to be in the early part of 2024, definitely in the first half. We're trying to get it there within the first quarter. Like I said, we're wanting to be able to demonstrate something at Intersolar, so go ahead and stop by. The development team is really focused on this, so it's a real high priority. If not the first quarter, I would say the second quarter we'll see it. So stay tuned. You can bet there will be a webinar when that thing's ready to be seen. So watch for that. All right. Well, at this point, I would say we've made it through our questions. And so I think it's time to wrap up. I want to just thank all of you who have attended. We had a really good turnout. Really appreciate. And so just appreciate it. As mentioned, we're going to be emailing you the slides as well as the recording of the webinar, so you can watch your inbox for that. Go to plantpredict.com. You can register for a free account online, and then just reach out to us, and we issue free trials, which will give you access to to a Design Pro if you're interested in that. Stop by and visit us at Intersolar. It's another way that you can get a free trial. And just good luck with your designing. One question for contact info, again, go to www.plantpredict.com. That's best place to go. That's where you can fill out registration or register for a free account and ask questions and get all of our information. So plantpredict.com. All right, thanks everyone.